Hello everyone. Alright, so today what we're going to do is we're going to talk about how to clear fractions in equations and inequalities. So don't be freaked out. There are going to be times where we run into fractions, but what we're going to learn today is how to handle those and basically how to just get rid of them right off the bat, right? I'm not going to say it's going to be easy, but we can do this. So first off, we're going to be using a thing called a common denominator, right? So fractions are spooky, right? Common denominators are kind of our key to make them like significantly less awful to work with. So what we're going to do is we're going to find a common multiple that works for each different denominator, right? So what we're going to do, right? Let's say that I had a problem that looked like this: 2/3 plus 3/5, right? So one way that you can find a common multiple or a common denominator that we're going to use is you could take a look at the two different denominators, which in this case are just 3 and 5. And you could just multiply them together, get 15, right? So that's a real quick and easy way to get a common multiple that will work for what we're going to be doing, right? The other way that we can go about it, right, and this isn't as useful when you just have two different denominators, right? It's something that, we'll use more often when we have a bunch of different ones, right, is to, list out multiples of each one, right? So I'm going to list out some multiples of 3. So 3, 6, 9, 12, 15, 18, 21. I'm also going to list out some multiples of 5. All right, so let's give ourselves a little separator there. 5, 10, 15, 20, 25, 30. And what we're trying to do is we're going to be looking for the smallest number that they have in common there, right? Which in this case is 15, right? If I kept on going with the 3s, right? 21, 24, 27, 30, right? 30 would also match, right? So 30 is another number we could use, but 15 being a smaller number is good for us, right? Anytime you can work with smaller numbers, it's a little bit easier, a little less likely you make a mistake on it, right? So that's what I would suggest using here, right? If we do have something, like I was saying, where we have 3 different denominators, right, it can get a little bit trickier, right? I could take 6 times 2 times 8, right? Look at all these different denominators, multiply them together and see what we get, right? But that's going to come up with a number that's pretty large. We might not want to use that. I think in this case it'll come out with 96. So here's what my suggestion is going to be. I'm going to think about some common multiples again, right? So I'm going to have one for 2. I'm going to look at some for 6 and some for 8. What I would start with is I would start with the biggest of those numbers and see if you can kind of figure out what might work before you have to do the smaller numbers, right? Because just like we saw over on this one, I had to get through a lot more multiples of 3 to find things that worked than I had to work through multiples of 5. All right, so let's kind of run through it and let's see if it makes a little more sense. So let's start with the 8. 8, 16, 24, 32, 40, 48, 56, 64, right? So those are all those multiples of 8, right? I don't think we need to go too much further. Let's do it for 6. 6, 12, 18, 24, 30, 36, 42, 48, all right? And already, when I just have those 2 larger numbers done, I can take a look at what they already have in common, right? I'm noticing that 24 is something they have in common. We could also work with 48, right? But that 48 is already bigger than 24, so preferably we'd like to use the 24. Right. The reason that I say start with the bigger ones is that, then I can work on the 2 and I can say, like, all right, if I kept writing out multiples of 2 like I'm starting to do there, I know that one of those I would get to is eventually 24, right? We could keep counting up by 2s and we'll get to 24, right? So in this case, 24 turns out to be a real good candidate for what we want to use. If you didn't catch 24 being the same, eventually you would also reach 48 with that as well, right? But again, what I'm going to suggest here is we're going to use 24 as our common multiple here, right? So we're looking for the one that they all have in common. What we're then going to do with that is we are going to multiply everything by that common multiple, right? So let's go back to the actual part that you have on your notes, right? Let's talk through these steps first, and then we'll take a look at what that is, right? So here are our steps. All of these ones down here are exactly what we were working on with multi-step inequalities, right? Nothing has changed about them. The only new step is this first one, to find a common denominator and multiply through. So the only time we need to do that is when we have fractions floating around, right? If you don't have any fractions, you don't even need to worry about that step, right? But putting that step right at the start when we do have fractions means that our very first step is to get rid of the fractions, right? And make everything a little bit easier from there on out. Okay. So if you need to pause here and you wanted to write these down, feel free to pause and then unpause when you got them. All right, so let's take a look at this first problem here. We have 1/4 x plus 1/3 equals 7. Right, so again, what I'm going to do is I'm going to take a look at just those denominators, the 4 and the 3. And over here, what I'm going to do is I'm going to list out some multiples, 4, 8, 12, 16, 20. Do the same thing for 3, 3, 6, 9, 12, 15. And again, what I'm looking for is I'm looking for the smallest number that they share, right? In this case, 12 works. Right? So again, what we're going to do is we're going to take that 12 and we're going to multiply everything in the entire equation by that number. Right? So I'm going to multiply everything by 12. So I know that multiplying with fractions is something that you may not have done for a little while. So let's kind of talk through two ways we could do it. Right? One way is kind of the more traditional way, right? And if you want to use this first way, feel free to do that. After that, I'll show you kind of like a shortcut way that I like to use, but if that one doesn't make sense, stick with what does. So one of the ways that we can do this 12 times 1/4, right, this very first bit of distribution we're going to need to do here, 12 times 1/4 over to the side of here would look something like this. So 12 times 1/4. So I don't know if you guys remember from the last time that you've divided fractions in the past. If you have just a regular 12, you can divide it by 1, right? 12 over 1 is the same exact thing as 12. All right, so now what that lets us do is we can kind of line this up a little better. And then when I'm multiplying two fractions, the top multiplies the top. So 12 times 1 is 12. The bottom multiplies the other bottom. So 1 times 4 is 4. Right? So now we have 12 divided by 4, and we can simplify that to just be 3. Right? So that is a perfectly fine way to figure out that 12 times 1/4 x is 3 with an x there. Okay? So the other kind of shortcut way, right, and we'll kind of work through it on the same part here, is that I like to take this 12, right, and then I'm going to take it and I'm going to divide by the bottom of the fraction I'm multiplying with. So that will give me 12 divided by 4, which is 3, right? So when we do that, don't worry about that. We have a 3 that we just got from doing that step. After that, what we're going to do is we're going to take what we got, right, take that 3 and multiply it by whatever's on top of the fraction. Right, so 3 times 1 is still 3. Right, so we can get 3 that way as well. Right? If you like doing it the way that's on the right-hand side of the screen right now, go for it. Right, there's nothing wrong with that at all. I really do like that second way because it makes it a little bit easier to maybe do in your head sometimes. But either way will end up working out. Right, so let's take this 12, multiply it by 1/3 as well. So 12 times 1/3, right? If I do it out this way, 12 over 1 times 1 over 3, right? Multiply the tops together. 12 times 1 is 12. 1 times 3 is 3. 12 divided by 3 ultimately gives us 4. Right? So plus 4. Last but not least, right? Don't forget that we're doing this to everything in this problem, right? So we still need to do 12 times 7. Right, that's just a calculator one, or you can do it in your head, right? Whatever you feel more comfortable with. 12 times 7 is going to give us 84. Yeah. So from here, right, then it turns into a two-step equation, right? It looked awful at first, right? We had these fractions floating around, and nobody likes fractions, except for me, maybe. I don't know. But now all we got to do is just chuck some stuff to the other side, and then we're done. So here, when we have 3x plus 4 equals 84, our first step is going to be to move that 4 to the other side, right? So we're going to do the opposite thing. We're going to subtract 4 on each side to move that over. So what we're going to have is just 3x over there. Over on the other side, 84 minus 4 is just 80. And then we have 3x, which is 3 times x. Divide by 3 to get rid of that. And we're going to get that x is equal to, and this one's not going to be a nice answer. It's going to be about 26.6 repeating, right? I could write out 6666666, right? But 26.6 repeating is what we'll get there. And that's it, right? So again, getting rid of those fractions, it's not an easy step, right? But it does make the rest of the problem easier after we get through it. Right? Let's take a look at another one. So you have 2/5 x plus 1/6 equals 9. So something I kind of mentioned at the very beginning is that when you only have two different denominators, like this 5 and this 6, an easy way to get a common denominator or something we want to multiply by is to just multiply them together, right? 5 times 6 is going to give us 30, right? And that's something that we can use here. Off to the side, let's kind of talk through how it would look like if I did want to do it that other way, right? If I have a 5, I'm going to list out multiples of 5. 5, 10, 15, 20, 25, 30, 35. For 6, we'll have 6, 12, 18, 24, 30, 36. And we're still going to find that 30 is the smallest number that they have in common there, right? So 30 does work. So what we're going to do here, I'm going to try multiplying these with my other extra special way. I'm going to take this 30 that we're multiplying, and I'm going to divide it by the bottom of this fraction. So 30 divided by 5 is going to give us 6. Right? So ignore that now. We're left with just 6. I'm going to take that 6, and I'm going to multiply it by what's on the top of the fraction. So 6 times 2 is going to give us 12. All right, so we would get 12x from that. Right. Off to the side of here, if you are a fan of doing it the other way, or if you just want to see that, yes, it still works that way, let's take a look. We got 30. Again, we can put that over 1 times 2 over 5. Right, you multiply the tops together. 30 times 2 is 60. 1 times 5 on the bottom gives you 5. Oops, changed colors halfway through there. And then 60 divided by 5 gives us 12. Right, so we do end up in the same place no matter which way we do it. Right? After that, we have 30 times 1/6. Right? So again, I'm going to take this 30. I'm going to divide by what's on the bottom. So 30 divided by 6 leaves me with 5. Oops, let all that go away. So then I have 5. What I want to do is I want to then multiply that by that number on top. 5 times 1 is just 5. All right. Over on the other side, we still need to do 30 times 9. Right? And I know I didn't draw the arrows in on this one. If it helps you out to draw these in to kind of keep track of what you have and haven't done so far, go for it. 30 times 9 over there is going to give us all the way up to 270. Yuck. All right, but again, first step is getting rid of those fractions. After that, all I need to do is start moving some stuff around, right? This is a 2-step equation from here on out. So I'm going to subtract 5 to get that over to the other side. Right? So 270 divided by 5 is going to leave us with, subtract 5, not divide by 5, is 265. Okay. After that, we still got to get rid of that 12, right? 12 is 12 times x. So we're going to divide by 12 there. And on the other side, we're going to get that x is equal to 22.1. And if you're thinking wow, Mr. Pog, you're so smart, 265 divided by 12 in your head, right? I have them written out. If you don't trust me, 265 divided by 12 does give you 22 and 1/12, which, we're kind of rounding a little bit. It's about 22.1, right? So hopefully this doesn't seem like the absolute worst thing, right? Our very first step is to get rid of the fractions, right? Let's try another one out. So this one's got a lot of fractions moving around, but there's something that makes this a little bit easier than it might look. If I look at the different denominators, right, I have a 3 and I have a 5, but then I have just another 3 and another 5, right? So the only two denominators I have to worry about are 3 and 5. So if I did this part out over here, multiples of 3, 3, 6, 9, 12, 15, 18. If I did multiples of 5, 5, 10, 15, 20. Right? Those are the only two I have to worry about, and our lowest thing they have in common is 15. Okay, so what I'm going to do is I'm going to take everything, multiply it by 15. Right? When we do 15 times 1/3, again, what we're going to do is I'm going to take this 15, I'm going to divide it by the number that's on the bottom of the fraction. Right? So 15 divided by 3 leaves us with 5. Oops. So down there I have 5. I'm going to take that 5 and I'm going to multiply it by what I have on top. In this case, 1. So 5 times 1 is just going to leave us with 5 and that x that's attached to it. Right? We're going to go ahead and do the same thing for the rest. Right? So now we're moving on to 15 times 3/5. All right, let's take a look. 15 divided by the number on the bottom. 15 divided by 5 leaves us with 3. So we're going to take that 3 and we're going to multiply by what's on the top of the fraction. So 3 times another 3 is going to give us 9 there. All right, so plus 9. All right. What I'd like you to do is pause here, see if you can figure out what the other side is going to equal doing the multiplication the same way. All right, so hopefully you gave that a shot, right? If you're a little bit shaky on it, it's the idea is that we're trying to get better with this. So 15, we're now multiplying all the way over to there, but to 7/3. So we're going to start by dividing by that number on the bottom. 15 divided by 3 is going to give us 5. 5 times that 7 on the top is going to give us 35 there. So I have 35x. All right. Last but not least, all the way over there, we're doing 15 times 8/5. So we're going to do 15. We're going to divide by the number on the bottom. So 15 divided by 5 leaves us with 3. All right, so we'll take this 3 we got and multiply it by the 8 that's on top. 3 times 8 is going to give us 24. All right, and because there was a minus sign there, we'll still have a minus sign. It's negative 24 there. Alrighty. Oy, oy, oy. So what we're going to need to do from here is we need to go ahead and solve this out, right? We have x's on both sides. Let's see what happens. So in order to move all my x's to be in one place, what I'm going to do is I'm going to start by subtracting 5x from each side. I'm going to move all my x's over to the right-hand side. So those x's are gone from over there. We're left with just 9. Over on the other side, 35x's minus 5x's brings us down to 30x's. Right? And then that minus 24 still sticks around. Okay. After that, what we got to do is we are going to go ahead and add 24 to move that over to the other side. Okay. When we do that, 9 plus 24 is going to give us 33. Over on the other side, we just have 30x left over, right? Because those 24s are now gone. Okay. So I'm just going to zoom in there and give you guys a second to catch up if you need it. Although, as I said that, I'm like, wait a second, you guys are theoretically writing things down as we go. So whatever. So after this, what we're going to have is we're going to divide everything by 30 to get rid of that coefficient, right? So when we divide everything by 30, those are gone. We get just an x. Over on the other side, 33 divided by 30 is going to give us 1.1. Right? And that's all we need to get to. Right? I'd like you to do, I'm going to leave this one up here for a second if you wanted to pause here and try number 4, right? See how that one goes. So if you tried that out, let's take a look at it together. Oh boy, we got 4 different denominators, 3, 12, 6, and 4, right? So if you're really getting the idea of common denominators, like if you're like blazing ahead of everybody else, you might be thinking to yourself like, oh, I think I might know what it is, right? Just from looking at those denominators. But, what we can do is we can always double check, right? So I'm going to list out some multiples of 3, 12, 6, and 4. So 3, 6, 9, 12, 15, 18, 12, 24, 36, 48, 6, 12, 18, 24, 30, 4, 8, 12, 16, 20. Right, so we have all these different numbers that are multiples of each of those. And I'm looking again for the smallest thing they all have in common. And in this one, it might not be what you would expect, right? 12 is actually the smallest thing they have in common, right? It's one of the numbers that we actually started with. They all have 12 in common, so 12 is going to be a perfectly fine thing to multiply all of this by. All right, so let's go ahead. 12 times 2/3 x. So 12 divided by that 3 on the bottom is going to give us 4. 4 times the 2 up top is going to give us 8. So we'll get 8x there. When we do this second part out, 12 times 10/12. 12 divided by the 12 on the bottom of the fraction gives us 1. That 1 times the 10 up top gives us 10. So plus 10 there. Over on the other side, 12 times 5/6. 12 divided by the 6 on the bottom gives us 2. 2 times the 5 up top gives us 10 with an x on it. So 10x there. And last but not least for our fractions, 12 times 7/4. Right, so 12 divided by that 4 on the bottom gives us 3. And then that 3 times the 7 up top gives us 21. All right. So from here, hopefully we know what we're doing, right? We're just moving stuff around. I'm going to move my 8x's over to the right side. All right. So when I do that, they're gone from the left. I have 10 equals 2x plus 21. And then I need to move that 21 away from the x's. So I'm going to subtract 21 on each side. All right. When we do that, we're going to get negative 11 equals just 2x over there on the right-hand side. After that, we need to divide to get rid of that 2, right? Because it's 2 times x, so we're undoing that. Negative 11 divided by 2 is negative 5.5. And then on the other side, we just have x. Right. When you're getting to your final answer, something I guess I'll mention is that, leaving it, like plugging it into a calculator and saying like, oh yeah, it's negative 5.5, works out, right? That's perfectly fine. You could also say that, like another alternative answer is to just leave it as a fraction, right? Negative 11 over 2 equals x, right? That would also be a fine way if you don't have access to a calculator or you get something that's like a really gross decimal or something like that. Right. Either one of those would be fine. All right. So let's take a look at another one. Whew, this one doesn't look so bad. It's an inequality, but as we know, inequalities are pretty much the same thing as equations. We might just have to flip the sign whenever we multiply or divide, right? So let's take a look here. My two different denominators are 3 and 5. If you wanted to think about that 8 as one of those, you could think about it as 8 over 1, which doesn't really factor in, right? So what we can do is we've done this one before, right? 3s and 5s. 15 is the one we're going to want to multiply by. When I do 15 times 1/3. So we're going to take that 15, divide it by the 3 that's on the bottom, and that'll give us 5. 5 times the 1 that's on the top of the fraction leaves us at 5. So I have 5x. When we go ahead and do 15 times negative 8 in the middle, right, we don't really need that minus 1, or that divided by 1 underneath it. We can just do 15 times 8 regularly, which will give us, I believe, negative 120. Over on the other side, 15 times 1/5. Right, so again, take that 15, divide it by the 5 that's on the bottom to get 3. We're going to take that 3 and multiply by the 1 that's on top, and it's going to stay as 3. Yeah. 2 steps left. Right, we got to move that 120 away from the 5x's. So we're going to add 120 to both sides. And I keep forgetting to put my little separator line, right? You don't need it if you don't feel like it helps. I have been noticing that it does seem to help some people if you put that divider line in the middle. So if you like it, go for it. If you don't worry about it. What we're going to get is that 5x is greater than 123. And then to get rid of that 5, right, what we need to do is we need to divide by 5 on both sides. So we're going to get that x is greater than 123 divided by 5, right? We can leave it as 123 divided by 5 if we wanted to. Right, let's see what that actually comes out to be. Ooh, let's turn it into a decimal. 24.6. All right, so if you like using a calculator to like get an actual decimal answer, right? Perfectly fine. If you want to leave it as a fraction, you don't have a calculator handy, no worries. All right. So what I'd like you to do, try out the next one, right? See what happens. So hopefully you gave that a shot. All right, let's take a look. We have 1/6 x minus 2 is greater than 1/9. So this is one, where, writing out the multiples can actually be helpful to us, right? If you just said, oh yeah, let's multiply 6 times 9, it's going to give us 54. 54 would work, right? However, your numbers are going to be much bigger than they need to be. So let's take a look at some multiples of 6. 6, 12, 18, 24, 30. Multiples of 9, 18, 27, 36, right? Eventually we would get to 54 on each of those. But what I'm seeing is that 18 is a much smaller number to work with that they both share. So let's multiply by 18. If you tried it by 54, right, your problem might just look a little bit different than what I'm going to do here, but we should end up with the same answer at the end. All right, so when I do 18 times 1/6, 18 divided by that 6 on the bottom leaves us with 3. 3 times that 1 up top stays as 3 with an x on it. When we do 18 times -2, that's just regular old multiplying. That's going to give us -36 there. And then 18 times 1/9 on the other side. 18 divided by the 9 is 2. 2 times that 1 up top stays as 2. 2 steps left. Got to get that 36 away from the x's, so we're going to add 36 to both sides. So those 36's are gone. We're left with just 3x. 2 plus 36 gives us 38. And then our last step is to get rid of that 3 in front of the x, right? So x is 3 times x. Let's divide by 3 on each side. What we're going to get is that x is greater than 38/3, or again, we can take a look at what that's actually going to come out to be as a decimal if you did it that way. 38/3, we'll turn it into a decimal. 12.6666 repeating. Something, just like a small little thing, if you're not familiar with that symbol above the 6, that just means that it repeats. Right, I know we used it a little bit earlier, but if you've never seen it before, that just means that it's just like this answer that we just got, right? That 6 keeps on repeating, right? The reason it goes up to 7 is because the calculator is saying like, oh yeah, we're just gonna round that off all nice, right? Either one of those answers again would be fine. All right, let's keep on trucking. 3, 5, and 2. Ooh, these numbers don't seem like they're going to play out too nicely. And oh my gosh, the x is on the top of the fraction. What's going on? All right, let's take a look then. So our different denominators are 3, 5, and 2. We're going to figure out a common multiple of those. So 3, 6, 9, 12, 15, 18, 21, 5, 10, 15, 20, 25, 30. 2, 4, 6, 8. Who do we, oh, sorry, wrong thing. So what's going on here is that I'm already running through some numbers and I'm not really seeing anything that they have in common, right? So if you're finding yourself in a situation like this where it's like, I've listed out quite a few multiples and nothing seems to work, fall back to what we were doing or what we've been kind of talking about here and there, which is to just take all these different denominators and multiply them together, right? So that's our backup. 3 times 5 times 2, right? If I go ahead and plug that in, 3 times 5 is 15, times 2 gives us 30, right? So 30 will work for us. So let's use that. All right, so what we're going to do here, same old deal. And we're going to do 30 times x divided by 3. So on this one, we're going to treat it the same way, right? 30 divided by that 3 on the bottom gives us 10. 10 times x is just 10x, right? Nothing fancy going on there, just 10x. All right, after that, we're going to multiply 30 times negative 3/5. So 30 divided by that 5 that's on the bottom is going to give us 6. We're going to take that 6, multiply it by the 3 up top, and get 18. And it was minus, so we'll say minus 18 there. After that, we have less than or equal to, and then we're going to do 30 times 1/2. 30 divided by that 2 on the bottom gives us 15. 15 times that 1 up top brings us back to 15. All right, cool. So from here, again, just a couple steps to move things around. I'm going to get that 18 away from the x's. So I'm going to add 18 to both sides. I'm going to get that 10x is less than or equal to, what's that going to be, 33. After that, I need to get rid of that 10. So I'm going to divide to get rid of that coefficient. And we're going to get that x is less than or equal to 3.3. So something we haven't run into on any of these so far is having to flip our inequality sign, right? So something I do want to mention is that with these inequalities that we've been taking a look at, whenever we've been multiplying by something, right, we multiplied everything by 15, it was a positive 15. When we divided both sides, we divided by a positive 5, right? So we didn't need to flip our sign. Same thing here. We multiplied everything by positive 18, so it was fine to leave everything the same. Later on, we divided everything by positive 3. So again, perfectly fine to not flip our sign. It is something that you still want to be careful of, right? Say towards the end of this problem, or say we adjusted it a little bit. I'm going to do it in blue here. Say that was a negative x. This was a negative 10x all the way through. That's where we would end up having to flip our sign because we then would have divided by a negative number. Right? We didn't do that here, so we didn't have to worry about it, but it is something you don't want to forget about because when it does pop up, you want to make sure you get that right. All right, we'll take a look at 2 more that are a little on the tough side, and then there's a word problem that I'm going to leave as optional. If you want to stick around and listen to me blabber on about it, you can. If not, that's also okay. But let's talk through 8 and 9 first. So for 8, what I'm seeing is that we only have 2 different denominators, right? So what I'd actually like you to do is take a second, figure out what common thing we might want to multiply by. And it might not be what you think, right? So stop after you find it out and then see if you got the same thing I got. All right, so hopefully you gave that a shot, right? So our 2 different denominators are 2 and 6. So let's list out some multiples. Let's see what the smallest thing they have in common is. Sorry for that noise. There's a bus going outside my classroom. So if I'm looking for the smallest thing those have in common, you might be like, oh yeah, it's 12. I'm seeing that 6 is actually the smallest we got, right? So again, if you found 12, that would still work, right? Don't feel bad about it. There's nothing wrong with using 12. Using 6 might just make our lives a little bit easier. So I'm going to go ahead and let's multiply everything by 6. So I'm going to have 6 times 7/2 x. So again, I know it's been a little while and we've been kind of running through these multiplying parts. I'm going to kind of run through it a little bit more slowly again for at least part of this problem. We've got this 6 and we're multiplying it by 7/2. So what I'm going to first do is I'm going to take that 6, I'm going to divide it by the bottom of the fraction. So 6 divided by that 2 is going to leave me with 3. Now that I've taken care of that, I'm going to take that 3 that we got, I'm going to multiply it by that 7 that's on top. So 3 times 7 is going to give us 21 with an x attached to it. All right. Let's also run through it just for the second one. All right. We're taking this 6 and we're going to start by dividing it by that 6 that's on the bottom. All right, so 6 divided by 6 is going to leave us with 1. We're going to take that 1 and multiply it by the top, which is 11. 1 times 11 is 11. So I'm going to say minus 11 there. All right, it's the same deal pretty much on the other side. When we do it times 13 over 6, 6 divided by 6 is 1 to take care of the bottom part. We'll take that 1 and multiply it by the 13 up top to keep it at 13 with an x. All the way down the end there, we're going to multiply by -3/2. So 6 divided by that 2 on the bottom leaves us with 3. We take that 3 and multiply by the 3 up top, which brings us up to 9. So we'll say -9 there since it was negative to begin with. Cool. So again, first step was to get rid of the fractions. Whew, looks much better than when we started. Now what we need to do is move things around and just figure out what our final answer is. So I'm going to move all my x's to one side. I'm going to move those 13x's over to be on the left. All right. So 21x minus 13x is going to bring us all the way down to 8x's. Minus 11. On the other side, we just get -9. After that, all my x's are over on the left-hand side, right? All 8 of them are over there. That means that I need to move this 11 to the other side. In this case, we're going to do that by adding 11 to both sides. So we're going to get that 8x is greater than 2. Right? And again, so far we haven't multiplied or divided both sides by a negative, so our sign is still facing the same way. And I think based on what we've got here, it's going to stay that way. We have 8x, so let's divide by 8 to get rid of the 8. We're going to get that x is greater than 2/8, which is the same thing as 1/4, or, again, if you like decimals, 0.25. Either one of those is fine. All right. For the last problem, for number 9, like the last one that I'm going to have you watch through for sure, see if you can figure out the common denominator. See if you can get through the multiplying piece, right? See if you got it. Right. So hopefully you gave this a shot. Right? If you haven't yet, try pausing and give it a go. Right? It's not going to hurt. It's not going to bite, I promise. So we've got a couple different denominators here, right? 2, 5, and 20. All right. And again, what I'm thinking is let's start with the biggest ones. So 20, 40, 60, 80, 100. I don't think we're going to need to go all the way up to 100. 5, 10, 15, 20, 25, 30, 35, 40. All right, so we're seeing some things that already match. And again, 2 is pretty flexible, right? We can kind of imagine what all the multiples of 2 are, right? They're just all the even numbers, 2, 4, 6, and so on. So let's see what the smallest number that 5 and 20 have in common is. And what I'm seeing is that it's just 20. If I kept on going with the 2's, I'd get to 18 and then 20 and 22 and keep on going. Right? So 20 also works for that. So what we're going to do is we're going to take everything, multiply it by 20. Right? When we do that, and again, if you haven't paused yet to try this part out, give it a shot, right? This is something that, hopefully seems sort of okay by now. If not, we can talk about it in class for sure, but, worst that can happen is you're wrong, right? And that's okay. So 20 times 3/2 x. We're going to take the 20 and divide it by the 2 that's on the bottom there. So 20 divided by 2 is going to give us 10. We're going to take that 10 and multiply it by the 3 that's on the top of the fraction. So 10 times 3 is 30 with an x. Right? Would you look at that? The next part is the same exact fraction. It's also 3/2. So same process we just went through. 20 divided by 2 is 10 on the bottom. Take that 10 and multiply by the 3 up top to get 30. Over on the other side, 20 times -1/20. Right? 20 divided by 20 on the bottom is 1. And then 1 times 1 is still 1. So we're going to get -1 there. Last fraction, 20 divided by the 5 on the bottom leaves us with 4. We're going to take that 4 and multiply it by the 8 that's up top. All right, so 4 times 8 is going to give us 32. So we'll say minus 32x. Whoops. All right, from here on out, what we're going to do is we are going to move things around to get our x's all by themselves. So what I'm going to do here is I'm going to, first off, fix that line. Ugh. I'm going to add 32x to move that over to the left. All right. So over here we'll get 62x plus 30 is less than -1. Ooh, this doesn't look pretty, right? But it's going to be okay. All my x's are on the left, so let's move that 30 over to the right. So we're going to get 62x is less than negative 31. Ooh, and then what we're going to do is we're going to divide everything by 62. Gross. But what I'm going to tell you is that our final answer is not so bad, right? Let's take a look. Let's clear that out first. Negative 31 divided by 62 is just the same thing as negative 1/2. Or, again, if you prefer decimals, negative 0.5. Right? So, again, I'm not going to make you watch through the word problem with me. If you're interested in it, I am going to talk it through after this, but if you're leaving here, that's fine. Please be sure to check on Google Classroom for any additional stuff. If you have questions still, let me know. We can talk through this. Like I was saying at the beginning, this is not a particularly easy thing to do, right? There's lots of stuff going on in each and every problem, but if you just take it one step at a time and think about what you're doing in each step, hopefully it doesn't seem so bad. Right? So if you're sticking around, let's talk about number 10, talking about football. So in 2004, a long time ago now, Washington Redskins and the Cleveland Browns had the highest earnings in the NFL. The Redskins accounted for 1/12 of the league's income, and the Browns accounted for 1/15. Their combined income was $129 million. I want to figure out what the total income of the NFL was in 2004. All right, so you know me with word problems. We're going to read through one more time and kind of highlight important stuff. So 2004, highest earnings. Redskins accounted for 1/12 of the league's income. The Browns accounted for 1/15 of the league's income. Their combined income was $129 million. Right? And what we're asked to find out is what was the total income of the NFL in 2004. So, first things first, right? We got to think about what it is we're looking for. We're trying to figure out the total income for the NFL in 2004. I don't know what that is. So how about, let's use a variable to talk about it. Let's say that X is the total income of the NFL in 2004. So then what we can do is we can use those other pieces of information in our problem to work through that. So the Redskins accounted for 1/12 of that income. So the way that we can represent that is we can say, all right, 1/12 times X, right? It was 1/12 of that amount. The Browns accounted for 1/15 of that income, right? It's the same idea. We know that if we combine their incomes, right, if we add them together, that will equal $129 million. Yuck. It's a lot of zeros. So same kind of idea here, right? We have two fractions. What we're going to do is we're going to figure out something that we can multiply by to get rid of the fractions. So our two denominators are 12 and 15. So let's take a look at some multiples of 12 and 15. So 12, 24, 36, 48, 60, 72, 84. As for 15, 30, 45, 60, 75, 90. What I'm seeing is that they have 60 in common. Right? So let's use 60 here. It's not going to be pretty, right? If you have a calculator handy and you're trying to work ahead of where I'm at, this is definitely one to bust it out on. So we're going to multiply everything by 60. So the fractions won't actually be too bad, right? If we take 60 and we multiply it times 1/12, right? 60 divided by 12 is 5. Take that 5 and multiply by the 1 up top, leaves you at 5x, right? So 5x from that. When we do the second part, 60 times 1/15, 60 divided by that 15 on the bottom leaves us with 4. 4 times the 1 up top leaves us again at 4. Oh, and then on the other side, 60 times $129 million. So I'm going to bust out my calculator. 60 times 129, and million has 1, 2, 3, 4, 5, 6 zeros. Disgusting. Oof. So we're going to get 774, and then 7 zeros. 1, 2, 3, 4, 5, 6, 7. Let's see. 7,740,000,000. Oof. So what we're going to do here is we have some like terms that we can combine. If I'm looking at the left side of this, right, if I kind of separate the two sides, 5x and 4x, we can smush them together. They become 9x. On the other side, we have 7,740,000,000. Right? After that, easy peasy. To get rid of that 9, all we got to do is divide by 9. What could be more fun? All right, so those 9s are gone. We get just x. Phew, something's not so bad. And then let's see what 7,740,000,000 divided by 9 is. And so 7,740,000,000 and then million, 4, 5, 6 zeros divided by 9. Oh, perfect. It's just 8, 6 with 7 zeros. Just $860 million, right? So, pretty good. Total income of the NFL in 2004 was just a paltry amount, just $860 million. I don't even know if this information is 100% correct. That sounds pretty low for the NFL, right? But anyway, word problems, we can tackle them pretty much the same way that we did the other types of problems. So again, if you have questions about any of these, let me know. We can talk through this. Again, it's not an easy thing, so if it's making sense, kudos to you. Anyway, I'll stop talking for now. See you next time. Bye.